Okay, so here we go. Number 3. If 50 grams of NH4, oh shoot, forgot the 2CR2O7 were decomposed, how many grams of H2O gas would we expect to be produced? Okay, all right, so before we use the BCA table, all right, we have to put everything into moles. So I see my given is 50 grams of this very horrible looking, holy moly, okay, that. So I'm going to have 1 mole of that. We'll name it in a bit. Okay, and then we need grams of this. Whew. Okay, all right. So to get the molar mass of that, I'm just going to kind of cheat right now and look it up so it doesn't take me forever on the video. CR2O7. Let's see. And let's see what the molar mass is. Okay, all right, I'm still trying to find it. All right, so when you're finding the molar mass, if you have to find it, right, remember there's going to be 2 nitrogens, 8 hydrogens, 2 chromiums, and 7 oxygens. Okay, so you're going to add all that together, and the molar mass, assuming that this is correct, should be 252.07 grams per mole. All right, 2 nitrogens, 8 hydrogens, 2 chromiums. Yep, okay. All right, so 252.07. So 50 divided by 252.07 is going to give me 0.0. God, I should keep getting these weird numbers. 020 moles of this. Okay. All right. Okay, so I went ahead and balanced this one for you because it was not that tricky, but touch tricky. So I went ahead and balanced it for you already. Okay, so let's go ahead and see if we're going to be given this. Okay, and there's nothing else. So this is all product is all going to be 0. All right, so I'm going to start here. That's going to be 0. And then I'm going to use that as my base for everything else. Okay, so the reactant is the given, so that's going to have a 1 on the bottom. All right, and that's going to be a 1, and a 4. So this one's pretty easy, right, just to look at, right? Because if these are all the same ratio, if this is 0.2 moles, the rest of them are also going to be 0.2 moles, right? Because they have the same ratio based on their coefficients, all right? The water has a 4, so it's actually going to be 4 times as much, right? So that's going to give me 0.8. So that's 0.080 moles of water. Okay. And let's see, type of reaction, I'm going to guess, as best we can tell, this would be some kind of a decomposition, right? Taking a very complicated molecule and sort of splitting it apart. All right, and then word equation, 0.2 moles of solid. Okay, now we have to name this, right? So this is a tricky one because it has 2 polyatomics on it. Okay, so you have to remember when it's an ionic compound, it's just going to have 1 cation or positive ion and 1 anion or negative anion. Okay, so this is going to be solid ammonium. That's the NH4 plus 1 dichromate. All right, decomposes to form 0.2 moles of solid. Okay, now what's this guy? This CR2O3. Okay, so CR is chromium. Okay, and then O is oxide. All right, but you're going to have to recognize that one as one that's going to have a Roman numeral. Okay, because it's chromium is a transition metal. All right, so if the oxygen is -2, there's 3 of those. Right, so that's a total charge of -6, which means my chromium has to be a +6, which means that it's going to have to be a +3 charge. So it's going to be chromium 3 oxide. Ooh, that looks ugly. Let me try to erase that. Try again. Whoa, that wasn't what I wanted to do. Dichromate. Chromium 1, 2, 3 oxide. Okay, 0.2 moles of solid chromium 3 oxide and 0.2 moles of nitrogen gas and 0.8 moles of, water. And I'm going to just say water vapor, right? Because it's water gas. Or you could say water gas or gaseous water, whatever. Okay. All right. Now let's look and see what we actually wanted to find. It's actually the grams or the mass of water. Oops. Okay. So we know that we have 0.8 moles of water. Okay, and then that is, I think, 18.02 grams of water. You can work that out yourself. Okay, so 0.8 times 18.02. So 14.4 grams of water. Okay, so that's my final answer. All right.